What you just saw was how major data center clusters in Asia Pacific region grew in capacity over the past several years, and also how submarine network corridors expanded to provide interconnect capacity and replications for those data centers. Now let's take a closer look at what's driving these specific patterns of growth in distributed cloud computing. Now, with exabytes of data being created daily, these data need to be harnessed. They need to be stored and transformed to bring insights and to improve experiences. Now, this is where data lakes come into play. These bodies of data lakes with powerful CPUs and GPUs are now becoming centers of data gravity for enterprise systems, pulling other data and applications close, perhaps similar to the effect that gravity has on objects around a planet. Now, in the past, data centers were built closer to locations that are optimal for space and power. Now, storage-oriented data lakes are being built closer to end users. As data mass increases, so do the gravitational pull of these data lakes. Data gravity is determined by data mass, level of data activity, bandwidth, and of course latency. There are already several companies that publish data gravity intensity indices for major metros around the world. As you can see, high-intensity data gravity centers are mostly in highly populated urban metros. Given the ever-increasing gravitational pull-out data, we expect these clusters to grow even further while pulling other smaller clusters to be built in close proximity. Now, to mitigate power and space limitations in urban metros, we see these data centers growing in cluster fashion over optical WAN mesh underlays, including campus-style data centers. Now, gone are the days when hyper-mega data centers were built in remote corners of the world. Data gravity can however, create unforeseen barriers to digital transformation when you start factoring proximity to the users, i.e. latency, availability and cost of bandwidth, and of course the regulatory constraints, compliances and data privacy issues. Public clouds with their vast portfolio of services have long been seen as the obvious destination for enterprises to move all their workloads. However, given the egress cost, data security, over-dependency, and disaster recovery concerns, now majority of the enterprises are pursuing hybrid multi-cloud strategies while trying to navigate data gravity barriers. So in closing, let's take a look at how the industry is adapting to networking with data gravity. The first, the increasing adoption of multi-tenant data centers, also known as MTDCs. 63% of the enterprises still own and operate data centers facilities, and many expect to leverage these neutral MTDC co-location sites with low latency connectivity to multi-cloud ecosystems. MTDC is already a $50 billion global market dominated by real estate investment trusts, with majority of their revenue coming from co-location services. The second area is striving to build a balanced system. In a distributed cloud computing environment, there is a strong need for a balanced system to avoid resource stranding. A balanced system that strives to achieve optimal use between computing, storage, and network connectivity resources. We all know these three areas, they're growing at very different rates. Additionally, a balanced system also needs improved coupling with the application context. In an application-driven networking paradigm, applications really care about completion times of remote procedure calls, RPCs, not just about connection latencies. In this type of environment, network operators and the vendors have a key role to play in participating in this paradigm by building adaptive networks that are scalable, that have predictive latency, and that also have programmability with the relevant API exposure to the application providers. Thank you.